Hello everyone, I'm going to be showing you sort of a continuation of the previous video about everything basically just being bytes underneath the hood. That's not completely 100% accurate, but I think it's a really good way of thinking about how computers work. Everything can be pretty much represented as bytes, including functions. So this right here is some assembly code, and very easily we're just adding these two numbers here, and we're moving the result of our add into EAX, and then we are returning you can actually go to the website for this. Let me actually go to here. So if you actually go to Windows ABI and actually look this up, here we are. That is not the Windows ABI. If we go to here, you can actually see sort of the Windows calling convention. RAX or EAX is actually the return variable. Basically, this is our first parameter, this is our return, and I'm just using these very easily here. Now, this right here, if we compile it using fasm, that's the assembler that I prefer using, what we'll get is basically just 5 bytes as our output. It's going to be basically this. So if I actually open this up real quick, and I don't remember, IMHEX would probably be a better decision, but I'm going to use Notepad++. I use Notepad++ for this kind of stuff using their plugin here for hex editing. As you can see here, we have our bytes. So this is our different instructions. This is our return and our ECX, add ECX, and our mov ECX into RAX. So this is our instructions. This is the machine code. I believe if we could probably disassemble this using a disassembler, but anyway, basically the point remaining is that this right here was compiled into a bunch of bytes. Now, if we take those bytes and we read them in, so as we can see here, we're reading this into this variable code here, and it's just a void array. It could be a byte array. It could be anything we want. And this right here is our type that we're going to be casting to in a minute. We can allocate using virtual alloc. Now, virtual alloc is slightly special compared to what you might expect because it allows us to have execute, read, write. So we're able to specify exactly the kind of behavior that we expect out of our memory. We can allocate some memory that is executable. Now we're just checking to see if it's null. And if we do a mem copy, so we just copy our data into our memory here, we can now cast the memory. We're casting this memory right here, which is basically just a void star, right? That's what this is. This is a void star. We're casting this memory into our void star, into our memory here, which is a void star. We're now casting this to a function pointer. So again, this right here, our ifni, is literally just our function pointer. In fact, we could just do this if we want to. Right now, we're going to call that result here where we have, in this case, 10. So we're just going to call 10. That's going to be our result. Obviously, now we're just deleting it. I'm deleting memory. Realistically, we don't have to because, well, at the end of the program, our memory is going to be freed, and we're at the end of the program. We don't need it, but in this case, I have it just make sure you guys know that you're supposed to. It is a malloc kind of thing here. If we run this, we're going to get our main. Now, let's actually just compile this again real quick so we can actually just double check that our changes actually work correctly. Apparently, we do need our alias. That's fine, though. There we go. So now we have our alias working correctly. I'm pretty sure it's because of extern C. Regardless, now if we run our main.exe, we get the result of 20. That's because we obviously have 10 right here. Now, if we actually take our assembly and we do this a few more times, what you'll notice is, here we go, fasm2, func.asm. We rerun main.exe, we're going to get a different result, even though we never recompiled our code. If we modify this, we can actually completely change the result. So if we do an imol, I'm pretty sure this will change now. There we go. Now we got 100. If we do this again, we should get what, 1,100,000, something like that. There we go. So yeah, we just got 10,000 actually. So, again, right? We can change this. We can have this do anything. We can take this and do, what was it, like idiv or something like that? I don't remember exactly. And do this divide by like 10. Actually, let's just do divide by like 2 here. Let's actually double check that. Oh yeah, I'm doing divide incorrectly. I don't remember the instruction for divide. Yeah, I just don't remember the instruction for divide, unfortunately. Yeah, I just don't remember. Oh, that's a little bit unfortunate that I don't remember. But we can do subtraction. So we can subtract like 1,000 here, and that should work. There we go. So now we got our 900, or actually we got a negative 900 somehow. Anyway, point that I'm trying to make here is that this does work. It is so interesting that this does work, and it's literally just bytes. We're loading those bytes in at runtime and then executing them as an executable. We're just running the machine code by taking the memory, literally reading it in as code right here. This is just an array of bytes. In fact, if you want to see it, we can just let's just write this out actually. Let me just recompile real quick. There we go. Let's recompile. And now I want to do main.exe. These are the bytes. This is literally the machine code that we are executing. We're just taking this and executing it as machine code. That is it. That is our machine code. It's literally that easy. It's sort of a weird thing to think about, that you can just take memory from a file, you can stick inside of an executable set of memory that you get from virtual alloc here. On Linux, this would be a mem map. And if you just copy it in, cast it, and run it, and it works. It's sort of bizarre, but it does work. You do need to do virtual alloc or memory map because you need executable permissions, because this is obviously very easy to sort of abuse, and well, it's been used for security vulnerabilities in the past, so they sort of have it locked down. You can't just do it arbitrarily. Most stuff is not just writable and executable. Most of the time it's readable, executable, but normally it's not writable, readable, and executable. It's obviously a slight bit of a vulnerability, so they sort of try to limit how often you can just execute and write to stuff. But this is something that's actually used for things like JITs, of course. Anyway, hopefully this helps you understand, sort of how the computer works and understand memory and how compilers and other things in JITs work. Anyway, hopefully this was helpful. Have a great, wonderful, sublime day.